Find an equation in x and y for the plane curve defined by x equals 5 cosine t, y equals 2 sine t, when t is between 0 and pi. So in our last video, we eliminated the parameter by solving one of the equations for t and substituting it in the other equation. That's a good strategy, but not the best one here. When I see these trig functions, one of the things I want to think about is that I know a lot of trig identities. In fact, I know that cosine squared t plus sine squared t is always equal to 1. And I actually want to utilize that fact in this video to eliminate the parameter. So when I see x equals 5 cosine t, I can get the cosine part by itself. And then x over 5 is equal to cosine t. Squaring both sides gives me cosine squared t is equal to x squared over 25. I can do the same or similar thing with that equation. I get y over 2 is equal to sine t, and then sine squared t is equal to y squared over 4. Cosine squared plus sine squared is equal to 1. So if I do a substitution here where I have cosine squared, that's x squared over 25. Where I have sine squared, that's the same as y squared over 4 is equal to 1. And this is the equation of an ellipse. And I can quickly sketch that ellipse. A is equal to 5, 1, 2, 3, 4, 5. So I go left and right 5, 2, 3, 4, 5. Up and down 2. I know I'm centered at the origin with the x minus h and y minus k parts all being, x minus 0 and y minus 0. And so I can sketch this ellipse going through these points. And if you're really paying attention to everything on the board, you know if I trace the whole ellipse, I'll have made a mistake. All right, so I'm tracing out the ellipse, and I claim I've actually made a mistake in doing so. We'll pretend that's actually an ellipse. The scale's not perfect. Well, the reason I say that is if I just imagine applying some points, if I pick t equals 0, I'll be at this point here at 5, 2. At pi halves, I'll be at this point, 0, 2, and finally, at pi, I'd be over here. And so if I'm really paying attention, 0 to pi, I'm only tracing out the top half. And I can even put on the orientation. By converting into rectangular form here, I was able to quickly graph the ellipse. By paying attention to the parameter interval, I know I'm only dealing with the top half. So what I could tell my reader here is that this is really this ellipse, but only when y is positive, only when I get the top half.